Now this one will require a bit more work. So as you can see, no common base can be found. So we have to use logarithms in order to solve that exponential equation. So I'm going to use the natural logarithm. I have a subspot for the natural logarithm. So I'm going to write the natural logarithm and the natural logarithm of what we already have here. So that's going to be 3 raised to the power of 2x minus 7 and 7 raised to the power of x plus 2. So now we're going to have two exponents that are going to end up out here. So that's going to be 2 times x minus 7, and that whole thing is going to be multiplying the natural logarithm of 3. And on this side of the equation, we're going to have x plus 2 multiplying the natural logarithm of 7. But now we're going to end up with a bit of a problem here because we want to solve for x and we already have two x values, one on one side and one on the other side of the equation. So one thing that you can do here is proceed to expand this by multiplying the natural logarithm of 3 by both elements on the binomial. So that's going to get you at 2x times the natural logarithm of 3 and a minus 7 times the natural logarithm of 3. And on this side, you're going to end up with x times the natural logarithm of 7 plus 2 times the natural logarithm of 7. Then, because we want to solve for x, be a good idea to have all x terms on one side of the equation and everything else on the other side. So this is an x term, and this is an x term, meaning terms that have an x inside of the term. So let's write it as 2x times the natural logarithm of 3, and then minus x times the natural logarithm of 7. We're going to have all the other terms on the other side of the equation. So that's 2 times the natural logarithm of 7. And this other logarithm as 7 times the natural logarithm of 3. At this point, we could try to factor the x on this side. So if we factor the x, we're going to end up with x that multiplies 2 times the natural logarithm of 3 minus the natural logarithm of 7. And that's going to be equal to 2 times the natural logarithm of 7 plus 7 times the natural logarithm of 3. And now we can divide everything by. So you're going to end up with x is equal to 2 times the natural logarithm of 7 plus 7 times the natural logarithm of 3 divided by 2 times the natural logarithm of 3 minus the natural logarithm of 7. And just like that, we got our exact answer. And just by typing that into your calculator, you would get the decimal approximation. So just to show you and reveal what we just did, once again, going over the steps, we need to have two isolated exponential expressions. And we're gonna use, in this case, I use the common logarithm. On the previous process, I used the natural logarithm, but both will get you the final answer exactly the same. So you're gonna bring down the exponent, then you're gonna expand by multiplying the logarithm by both the x and the 2, and the logarithm, the common logarithm of 3 by the 2x and the 7. You're gonna end up with 2x terms. This 2x terms, you're gonna send or have all the x terms on one side of the equation and everything else on the other side. Then we're gonna factor the x. Once we have the x factor, we're gonna divide everything by this. And this is gonna be your exact answer, meaning that if you substitute this whole thing as the x here and here, you're gonna get the exact same thing on both sides. And this is your decimal approximation. So that won't get you exactly the same thing, but something very close on both sides.